Assalamu alaikum, dear student. This is Wajid Ali Shah, and I welcome you back to the video session of chapter number 4. Topic name is alternating current generator, or simply we can call it AC generator, which is given on page number 164. First of all, dear students, what is an AC generator? AC, the term used for alternating current. Alternating current is basically the type of the current which changes its magnitude and direction with respect to time. Generator is basically defined as the device which converts mechanical energy into electrical energy. That is what we call generator. So alternating current generator is the device which converts mechanical energy into electrical energy is called AC generator, or simply the device which is used to generate alternating current is called AC generator. The construction of AC generator is very much simple, and it is armature. Armature is basically a coil wounded around the cylindrical iron cylinder, which is the basic core part of the AC generator. Slip rings, these two are slip rings in the diagram, as we can see in the diagram that these two rings are slip rings because they are slipping across the carbon brushes, having a permanent contact with the external uh, terminals. Carbon brushes, these two parts are carbon brushes. The function of the carbon brushes is that it takes the charges or the current out of the AC generator to the external resistance attached. And a magnet. Magnet is obviously it's a very much important part of the AC generator. These are the two poles of the north pole and south pole of the magnet. What is the working principle of AC generator? The main working principle of AC generator is the Faraday's law of electromagnetic induction. What is electromagnetic induction? We have already discussed electromagnetic induction, that when a coil, a conducting loop, is rotating in a magnetic field, that magnetic field is produced by the north and south pole of the magnet. So when this coil ABCD rotates in a magnetic field, magnetic flux changes across the coil, across the loop, and electromagnetic induction take place. Induced EMF is there, induced current is there, and this is basically the generator, which is a device, which is a machine which obeys Faraday's law of electromagnetic induction, which is very much important for the electricity generated throughout the world, like in Turbela Dam, like in Mangla Dam. So, it doesn't matter if it is hydel power or atomic power or heat energy or anything else, wind power. So, Faraday's law of electromagnetic induction is there, and AC generator is there, and because of this AC generator, we have AC voltage and AC current. In our country, the frequency of AC current is 60 hertz. It means the coil is rotating 60 times in a second to produce the voltage 220 and the current I. What is the working of AC generator? I have written the working of this AC generator in a very simple sentence, like the coil ABCD. ABCD is basically the name given to this coil ABCD. Rotates in a magnetic field. That magnetic field can be shown by drawing lines from north side to south side. These horizontal arrows basically shows the magnetic field between the two poles of the magnet. So when this coil ABCD rotates in a magnetic field, external magnetic field, so Because of the changing magnetic flux across the coil, induction take place, electromagnetic induction take place, induced EMF is generated and induced current is also generated, and that's why we can call it alternating current or alternating voltage, because the direction of the current basically changes, varies, and the magnitude as well varies with respect to time because of the rotation of the coil. So, what is the working of the AC generator? Coil ABCD rotates in a magnetic field applied by the force of the magnet as shown in the figure, and generates electrical energy from mechanical energy. How we can rotate this coil in a magnetic field? We can rotate the coil in a magnetic field by any external source or anything else which should be an additional part of the AC generator, a mechanism which can be used for the rotation of the coil. That is additional part of the AC generator. So this mechanical energy is given to the generator from outside, and because of that mechanical energy, electrical energy is generated. In this system shown in the diagram, and that alternating current or alternating voltage comes out of the generator with the help of carbon brushes to the external resistance attached. Okay. Now we are going to explain the derivation of the equation of mathematical equation for AC generator. Basically, it is the Faraday's law of electromagnetic induction, which we have already derived and explained. But here in this mathematical part of AC generator, we are going to show that why do we call it AC? Why do we call it alternating current or alternating voltage? So, for the derivation of the equation for AC generator is, first of all, we should remind the previous concept of the magnetic flux through the coil. So magnetic flux through the coil is denoted by the phi, which is equal to B dot AN. A is basically area of the loop and N is the number of the loop. So to enclose the total area of the coil, we can multiply area of a single coil with number of the coil, so it becomes the total area of the coil. So number of the loops multiplied by area of a single loop gives us the area coil. So B dot AN, or simply we can write NAB cos of theta, where N is the number of loops in a coil, area is area of a single coil, and B is magnetic field, and theta is basically the angle between the magnetic field and area both. This is a concept which we had already discussed in the previous chapters. Okay, as we know that the coil is rotating in a magnetic field with some specific frequency, f or angular velocity omega. So from the previous topic from plus first year, we can see that theta is equal to omega into t, where omega is angular velocity, t is time, and this is angular displacement or angle theta. So we can put the value of angle theta in this above equation, this one, so we can finally write the flux is equal to NAB cos of omega t. We have put the value of theta omega t, and it becomes the equation for flux. Now as we are going to drive an equation for the induced EMF, which is alternating EMF basically. So we use Faraday's law of electromagnetic induction. Induced EMF is given by Faraday's law of electromagnetic induction. EMF is equal to minus delta phi divided by delta t. The rate of change of the magnetic flux induces the EMF in the coil, which is responsible for the production of the current in a coil. So EMF is equal to minus delta. We can put the value of the phi. We can put this value of the phi in this equation and have this one. So delta into, we can put the value of phi from this equation here, and we can make the equation like this: NAB cos of omega t. So Negative is taken outside. In AB they are constants, they can also be taken outside, and we can write delta cos of omega t divided by delta t. It is a function, and it is a derivative. I think it can be taken from class first year mathematics or second year mathematics, derivative calculus. So we can simply write that EMF is equal to minus negative NAB, and we can write delta cos of omega t divided by delta t. This is, in calculus, it is equal to minus omega sine of omega t. It can also be proved separately, but this is not a topic here which can be completely shown here. So this can be taken with reference from mathematical subject. Okay. So EMF, negative multiplies and give us positive omega NAB sine of omega t, and this is a part I have written omega NAB. This is constant. Omega N is number of the loops, constant. A, area of the loop, constant. B, magnetic field, constant. Actually, we can vary the angular frequency, angular velocity of the generator to increase or decrease the current or the voltage. But in our country, the voltage which we can use 220, or the current which we can use, the frequency for that current is 60. So for that 60, we can take this omega as a fixed value. Okay, so omega NAB sine of omega t. To take the maximum value of, so for taking the maximum value of the EMF, we can take this component equal to 1. So if we take this equal to 1, so we can get EMF maximum is equal to omega NAB, and we put this value here. So EMF, instantaneous EMF, is equal to EMF maximum sine of omega t, or simply we can write EMF is equal to EMF maximum sine of 2 pi f into t, because we know that from first year class that omega is equal to 2 pi into f. So as we can see the equation, that this is a sinusoidal equation which we have already explained in class first year. Again here in the topic of phase for AC, and this sine is a sinusoidal function. It varies with time. So this equation gives us a waveform like this. So sometimes the value is 0 as the time passes and the rotation of the coil starts, so voltage increases to maximum value, and for further increasing the value, it again comes to 0. Again the direction of the coil is reversed and it goes down, negative, and then it is 0. So the value of the induced EMF by this generator is variable, sometime increasing, sometime decreasing, sometime going positive, sometime negative. So for that reason, it is a sinusoidal function. This function shows a variable value, 0, 90, 90, then 180, then 270, then again 0. So it basically shows a cyclic repetition of the values. So for that reason, it can be said like alternating current generator. Thank you. Have a nice day.